And then they had probably a piece of wood or a stone, something like that, where they had like the square root of 2 is 1.41, the square root of 7 is 1.73, the square root of 5, the square root of 6, and they had all the square roots written down somewhere. And probably the math people just carried their rocks around with them, or their pieces of wood, or maybe they had paper, some kind of paper. Maybe. Yeah, maybe. But that is pretty much how they did their math. So like they did it all in exact form, and then they had something that probably 2 people in their whole little colony area, or little whatever they lived in. I don't even know what they were called then, because we're talking about like both Babylonian and Pythagorean times. So. Cities, yes. Okay, so they had cities then. So they found everything exact, and they just had crazy minds that were able to do that. Not that we don't have crazy minds, but we have all the technology, so it helps us. So we are going today try and find angles that we still can find on the unit circle, like a 75-degree angle, but we're going to use the angles we know to find an exact value for that. So instead of just pulling out that calculator and typing in the sine of 75, which, I mean, you could have done that like when you were in kindergarten, as long as somebody said, just hit sine and hit 75, and boom, there you have a number. So we're going to see if we can find the exact value of as many angles as possible. Now, you still can't find all of them until you essentially learn a whole bunch of formulas, and we're going to only do some of them. There's even more that you'll get as you work through math if you decide to go that route. So, looking at the formulas in the box, there are 6 of them because you have a sum, adding 2 angles, and a difference, subtracting 2 angles for each of the 3 main functions. So this is the cosine. If you prefer to use an A and a B instead of an alpha beta, that's fine. If you look at the sheet that you picked up when you came in, I think it uses U and V. As long as you know they're 2 different angles. Whatever variable you want to use or letter you want to use is totally up to you. But the cosine is the weird one, because it says the cosine of adding 2 angles is equal to the cosine of A, cosine of B, minus sine of A, sine of B. And you would think that if you're adding, your formula should include adding. But there's a really cool proof, maybe Cade will think it's really cool, on page 400, that you could look up and see why it's a minus sign. Brandon might do that too. Brandon, you don't have to do it now. But it involves using the distance formula and the Pythagorean identities, the Pythagorean formula. But it does show you on page 400, and actually there's like 5 pages in there that gives you a bunch of proofs. Maybe it's 4, Brandon. There's a couple pages after the chapter that show you proofs as to why the identities exist and how these formulas were created. So feel free to take a look at that at some point. You don't have to though, but if you have a little bit extra time, you're like, ooh, I want to see. But it does show you why like the formulas are created. So the way these work, we're going to start off with a basic angle of a degree value because it makes a little more sense to do it in degrees first. Find the exact value of the sine of 75 degrees. So your goal first is to think of 2 angles that would combine to be 75 degrees that you know from the unit circle. So you have to be able to know the angles in order to evaluate it. If you tell me 15 plus 55, no, 15 plus 50, 65, if I could add right, 60. Maybe I'll just stop talking. So 15 plus 60 is equal to 75. I'll say yes, but you don't know how to find a 15-degree angle, so we can't use that angle. So Virginia, hopefully your math is a little better than mine. 2 angles that add together to be 75 would be?
45 and 30.
Yeah, so you could use 45 plus 30. I said 5. There we go.
Okay,
Yeah, I am. Just, I'm hot. It's like roasting in here.
It's very hot in here.
It is
All
really
this
hot.
cold.
Like, right? 2 other angles. What else could you choose? If you didn't want to use 45 and 60, how could you make it a subtraction problem, Brandon?
90 minus 32.
Yeah, oh, because we don't know 15. Any other angles that we could use? I'm sure there are. Could use like 135 minus 60. That wouldn't. Yeah, that's good mental math there. So we could use 135 minus 60. 135 is an angle on the unit circle. That's a 45-degree angle. So like you don't have to use basic ones that are in the first quadrant. But the goal is for you to pick 2 that you know. So the ones you know are probably probably in the first quadrant. And then we are going to take the sine of the sum of those two angles. Now here's the trick. Those parentheses don't mean distribute the sign through the problem, because it doesn't really work that way. So this isn't multiplication. This is a function of those two angles. So I can't just be like distribute, and be done with the problem. Instead, you need to go up to the little chart, or on your identity sheet, and find the formula that goes along with the sign of adding two angles together. And we're going to apply the formula to those two angles. So we have sum, so we're using the sum formula. And the sum formula for sine says take the sine of the first angle, which is 45 degrees, times the cosine of the second angle, which is 30 degrees. So I'm just taking the two angles, plugging them into the angle location in the formula. We're adding that to the cosine of the first angle times the sine of the second angle. So you're plugging the angles into the formula, and then you're evaluating them, because hopefully you have them memorized. If not, hopefully they're memorized pretty soon. So Brandon, if we look at the sine of 45, the sine of 45 is?
Square root of 2 over 2.
So now I'm replacing the sine of 45 with its numerical value from the unit circle. Brandon, the cosine of 30 is?
1/2. No, square root of 3 over 2.
There you go, square root of 3 over 2. And then on the other side, Brandon, the cosine of 45 is still?
Square root of 2 over 2.
And the sine of 1/2, or 30
1/2.
is 1/2. There we go. So you pick your formula because we're adding two angles together. You plug in those numbers. Virginia? Not-
It doesn't switch.
Yeah, not for sine. Sine actually stays the same. Cosine's the one that switches. And then you multiply. So when you multiply the square root of 2 times the square root of 3, what do you get? Michael? Oh.
What would be square root of 2 times square root of 3 over 2?
Yeah, can you multiply them? Yes. You are allowed to multiply them. As long as they're both square roots, the root part you're allowed to multiply, the number underneath. So you can multiply those and get the square root of 6 over 4, multiplying the bottom. And then on the other side, the square root of 2 over 4. So you are allowed to multiply radicals together if they're the same radical. Can you add them together? No. So just like variables, we can take 3x times 2y and get 6xy. But we cannot add them together because the variable isn't the same. So you're allowed to multiply the radical together, but you can't actually add them. I believe the back of the book might pull out the 1/4 and separate it from the radical, because technically a rational number, which is a number that can be written as a fraction, is supposed to be separated from a radical number. They don't like to mix. So the 1/4, they both have a 1/4 in common. That usually gets factored out, and then the radicals are separate. So 1/4 is square root of 6 plus the square root of 2. And that's it. So I know that answer seems weird, but we're so used to having the square root of 3 over 2, the square root of 2 over 2, 1/2. Like those are the numbers that we're used to seeing on the unit circle. If I were on the unit circle and I had a 75-degree angle, this would be the y value, because sine is y. So that would be the y of that point, the y coordinate of the point for a 75-degree angle. Question? So if you look at the one right next to it, it's the same problem, type of problem, except the angle is now a radian angle. We're going to solve it the same way, but now we're going to think about radians. So find the exact value of the cosine of pi over 2. So your goal, just like with 75 degrees, we had two angles that added together to be 75 degrees. Now we're trying to find two angles that can combine to be pi over 12. And I want them in radians. So two angles, the values that you have kind of memorized from the unit circle, what two angles would combine to be pi over 12? Sabrina?
Would it be pi over 3 minus pi over 4?
Said pi over 3 minus pi over 4? And what were you thinking about when you decided on those two?
Well, I mean, first I was trying to figure out what would get the base of 12, and I
Yeah.
figured out that 3 and 4
So a good way to think, she said, you have a denominator of 12, and thinking about common denominators, the 3 can become a 12 by multiplying the top by 4. The 4 can become a 12 by multiplying the top by 3, and then we could take 3 minus 4. So that would work. So that would give us pi over 12. With the fractions, it's a little harder because you're going to have to think of common denominators and how would they add or subtract to give you that pi over 12 value. So now if we plug it into the cosine, we have the cosine of pi over 3 minus pi over 4. Those two numbers together make pi over 12, and if I use those two values and the difference formula for cosine, then I can find the exact value. So see if we can try and look up above, get the difference formula for cosine, and write that formula out, plug in the angles, and then we'll try and evaluate that. That's you. Just be careful with the sign in between. Squeeze that guy in there. Thanks, Peter. Have a good weekend. Thanks. So Libby, do you know what the cosine of pi over 3 is?
Like 60.
That is a 60-degree angle, but what's the actual cosine of that angle?
Oh, that would be square root of 3 over 2. Or
That's the sine.
1/2.
There you go.
Yeah.
1/2. So the cosine of pi over 3 is a half. The cosine of pi over 4 we already used over here with 45 degrees. We said that's the square root of 2 over 2. The sine of pi over 3 is the square root of 3 over 2. And then the sine of pi over 4 is the square root of 2 over 2. So Kate, when you multiply the left together, you end up getting,
The square root of 2.
and when you multiply the right, you get,
Square root of 6.
and if I factor out that 1/4, you get the square root of 2 plus the square root of 6. Brandon, do you know why it's exactly the same?
Nice.
So there is a reason that we learned, actually this chapter and last, Michael.
It's because pi over 12 is 15 degrees, so 75 is 15.
Yeah, so pi over 12 is a 15-degree angle. 75 degrees and 15 degrees make 90. The sine of 75 is equal to the cosine of 15 because they are cofunctions, which we talked about back in chapter 4, and also we have that identity on that sheet, the cofunction identities. But if you have two angles that are adding to be or complementary angles, the sine of one and the cosine of the other, they're cofunctions. The secant of one and the cosecant of the other, the tangent of one and the cotangent of the other. Those are all the cofunction identities. So they happen to be the same because the angles add up to be 90. Questions? So this is one type of problem that we can use the formulas for. There are actually 4 different types of problems, and I got like one, this one you get 2 here, but like one type of example just to see the different ways that we can work through the problems. So the second type of example that we might encounter are going to give us values for sine and cosine, because this isn't on the unit circle, it's now has a different sine cosine value, but it's still going to give us numbers that we can use to try and evaluate. So this one, find the sine of an angle A plus B, so the sum of 2 angles. Given the fact that the sine of the first angle is 4/5, and it's in the second quadrant, pi over 2 to pi is quadrant 2. So this is quadrant 2 right here. The other angle, angle B, has a sine value of unrationalized -2 over the square root of 5, or rationalized -2 squared to 5 over 5. And it says it's between pi and 3 pi over 2, So that means it's in quadrant 3. So this is not a unit circle problem because 4/5 is not a number on the unit circle. So we can't use the unit circle for this one. If we don't use the unit circle, what other way do we work through a trig problem? So it's either unit circle or identities or not a calculator, Chelsea, a triangle. So kind of like 3 different things that we've been working on. It's either on the unit circle, we draw a triangle, we try and use an identity. Those are like the 3 things that really encompass the trig stuff that we've been going over. We're going to do that third thing, we're going to make a triangle. Because if you have sine, Chelsea, the sine are what 2 sides of a triangle?
The hypotenuse and the opposite.
Yeah. So we can label the triangle with those 2 sides and find the third side. This one is a 3, 4, 5 triangle, which is nice. So I'm going to put the little angle here so we know that that goes with angle A or alpha, whichever one you want to use is totally up to you. Fishy A. Opposite is 4, hypotenuse is 5. Brandon said it's 3, 4, 5, but be careful that 3 is negative because we're on the negative x-axis. There's one triangle, but they give us 2 pieces of information, so we're going to draw a second. That second is now in the 3rd quadrant, and I do draw it on a separate graph because they have different x values. They're not sharing the same x. And this is B or beta. If you use the unrationalized form, it's easier to label the unrationalized because we know the separate values of the sides. So the opposite is -2. The hypotenuse is the square root of 5. Use the Pythagorean theorem to find the adjacent side. So what would the adjacent side of the x side be of this triangle? Brandon? A 1, and again it's negative because we're on the negative x-axis. Okay, so we drew 2 triangles with the different angle values that they gave us. Our goal is to find the sine of A plus B. Sine of the sum of 2 angles. So if you go and grab that formula, I'm going to just write the formula first in its expanded form. Just to kind of remind us. So we're going to use the sine of A times the cosine of B plus the cosine of A times the sine of B. That's the formula that goes along with sine alpha plus beta. So what do you think you would do with this formula and the 2 diagrams that we have drawn? Chelsea?
Just plug in the values.
Yeah, just plug in the values, which is what we did before, except we had the cosine of pi over 4. Well, we don't have the cosine of pi over 4, but we know the values that represent these angles. So the sine of A, here's my A, 4/5, so take it out, replace it with its value, which is exactly what we did above, but we used numbers from the unit circle. Cosine of B, so go to angle B, right here, that second one, and we have -1 over the square root of 5. So cosine B, -1 over the square root of 5. I suggest putting the rationalized value in because then you have a common denominator. And rationalize, that's negative square root of 5 over 5. Hey, I have the review. See if you can plug in the other ones. Keegan just gave me that. I think I forgot to give them to you after I was done yelling.
Oh, yeah. I forgot how to.
Okay, this is not late.
And this one.
That one is.
Okay.
And here are the others.
Thank you.
Thank you. And these are mine. Yeah. Yeah. It is so hot in here.
That's
Yeah, I'm roasting. Oh. I can't reach that up there. So.
Just climb on the camera.
Well, I think I shouldn't climb in front of everybody. It's probably bad. All right, so Brandon, can you just quickly tell me the values you plugged in for cosine A, sine B? Thank you, Santiago. Have a great weekend. Thanks. Did you plug in numbers, Brandon?
No, I was kind of paying attention to what you were doing.
Anybody plug in Sabrina? Thank you. I'll be sure.
Negative 3 over 5 and negative 2 times the square root of 5 over 5.
Thank you. And again, that's from using the triangle on the left for A, the triangle on the right for B. And then when you multiply them, Sabrina, what'd you get when you multiplied the first two together?
Negative 4 times the square root of 5 over 25.
And then when you multiplied the second two together,
6 times the square root of 5 over 25.
what do you notice about these two fractions?
You
You can actually add them. So these fractions you are allowed to add because they have the same radical. So adding the numbers in front gives us 2 square roots of 5 over 25. And for some reason, it just seems like a nicer answer when it's in one fraction instead of having those two separates. Questions? So I think like the first 2 or 3 problems, like you'll have, they're going to be similar to this, where you'll create 2 triangles and then you'll evaluate the sum formula or the difference formula for the function. Questions? Bryn?
When making the unit circle, did they have to think of like all of these different things, make sure that they all worked, and then they can make it?
Correct, yeah. So like there's a lot of stuff that went into creating that unit circle. And we just can use it because somebody created it for us. Well, that was kind of like their lives back then, though. And if you were a mathematician, that's just what you did. And
Are people still making like?
there are people that are still, like that is what they do. So they are still trying to come up with new math. So even the professors at the universities, like they're still trying to create something to produce some kind of document to show that they've found something
New formulas to make their life
Yes.
easier.
to make your life easier, yeah, essentially. Questions? So there are 2 other problems that we're going to look at. If you have the identity sheet on your page, this one's like a matching game. Match the formula. So this is called the expanded form. We have the sine of a 42-degree angle, which we don't know what that is, the cosine of a 12-degree angle, minus the cosine of a 42-degree angle times the sine of a 42-degree angle. And it says to find the exact value again. So if you kind of just look to see the form that you're given, look at the 6 sum and difference. We're only dealing with sum and difference right now. Which one does that match to? Virginia?
The sine A minus B.
Yeah, so on your sheet, I use the angles U and V. So that matches with the sine of A plus B or the sine of U. Did you say plus or minus? Minus, sorry. Minus B. So the sine of one angle minus the other angle. And in our case, we're talking about the sine of 42 degrees minus 12 degrees, Virginia, which really makes, yeah, the sine of a 30-degree angle. So this is kind of the other way to look at the problem, or approach the problem, starting with the expanded form and then trying to break it down and simplify. And the sine of 30 degrees is
Square root.
other one. 1/2. Yeah. So the sine of 30 degrees is a half. So now when like there's not really much you're doing there, you're just recognizing which formula do you have, and then adding or subtracting the angles based off the formula that you're given. Any questions? So the very last one is an equation, which that's kind of the whole goal. So we learned the equations over the last 4 days. We worked through trig equations. So this one now is a trig equation with the sum and the difference formulas in them. And our goal is to find x. So kind of taking all the stuff we've been doing and now trying to get the x variable in this equation. It looks like it should be pretty long and involved, but there are really 2 formulas. So look at the formula for the sum of the sine. So this is angle A plus angle B, and we're going to expand it. So that's the first thing we're going to do. We're going to take this little notation and expand it using the formula. So this is the sum for sine. If it was cosine, we'd use the sum for cosine. So we have, bless you, sine x cosine pi over 4. Plus cosine x sine pi over 4. Those two pieces make that first part. That is in addition to the difference for sine, so sine x cosine pi over 4, minus cosine x sine pi over 4. And all of that is supposed to equal -1. So we're expanding it. We're making it bigger before it's going to condense and become smaller. So I just took the two formulas and I replaced the notation with its expanded form. I know it's really large to look at, but you should notice something, Brandon.
The cosine x sine pi over 4 cancels out.
Yeah, so they're the same. Cosine x sine pi over 4, one's positive, one's negative. What else, Brandon?
It would be 2 sine x cosine pi over 4.
Those guys are identical. If you have x plus x, you make it 2x. So now we have 2 sine x cosine pi over 4. And that's equal to -1. So that huge list condensed to give us one part, one group of terms. And then there's something else we can do yet.
Divide by 2.
We could divide by 2. What else could we do? Like,
You replace the cosine pi and 4 with square root of 2.
yeah, we can replace this with the square root of 2 over 2. I'm going to just put this in parentheses so you can kind of see they're all pieces being multiplied. Brandon, you're not wrong by any means. You could have definitely divided by 2. But if we don't divide by 2, I have this 2 over 1 and the square root of 2 over 2. And nicely, those 2's would cancel and leave us with the sine x and a square root of 2 in front. So multiplying 2 times the square root of 2 over 2, the 2's cancel out, leaving us just with the square root of 2. And then getting sine by itself. Now divide by that number, but we're dividing by the square root of 2. So the last part of this question now goes back to the solving. We want x. Where on the unit circle is the sign negative square root of 2 over 2? So think negative third and fourth quadrant. Sabrina? She said 5 pi over 4, that's the third. 7 pi over 4 is the fourth. Anytime you have that square root of 2 over 2, that's that pi over 4 family. Questions? So I think for the most part it's pretty straightforward because you're using a formula over and over and over again. But it's the formula part, kind of looking at those as you're working through the homework. Questions? When? You'll have to memorize. So,
Merry Christmas.
hopefully you enjoy your 3-day weekend.
Oh, I will. I will be sleeping for about 50% of it or more.